Hello everyone. Title of this video is Section 4.4 Part 2 on solving applications using systems of linear equations in three variables. So whenever you see the word applications show up in a section, it usually means you're working on word problems. Alright, so in this video I'm going to be taking you through a version of the Knewton Alta assignment for Section 4.4 Part 2. Now please be aware that the questions you are seeing me do in this video are not necessarily going to be the same exact questions you'll see when you work on the assignment on your own. But the objective will be the same, the types of questions will be the same, how you would do them would be similar. So I'm hoping that watching me go through the assignment here will help you when you work on the assignment on your own. Alright, so let's get started. So here's the assignment page. You will not see the word preview. This is because I'm a teacher here, an instructor. You'll see the title of the homework, the mastery bar telling you how far along you've gotten, and then the objectives. Now, as I mentioned, there's only the single objective here. Solve applications using systems of linear equations in three variables. Then you have your questions, and there's a feedback button where you can send feedback to Knewton about a question if you want. You will not see the instructor cheat button. Alright, that's only for instructors. But you will see the more instruction button. Alright, and that's if you're struggling with a question or a type or an objective, click on the more instruction button and some additional reading material or videos will show up that hopefully will help you working on those kinds of questions for whatever objective you're on. Alright, so the first question. Now, like with any word problem, and these will be pretty short from what I've noticed reading through the questions myself beforehand, you read through the question, read through the problem, identify any unknowns, right? What do they want? What are they asking for? And call them some variables. Now they're going to be telling us here the variables they want us to use. You could use other variables if you wanted, but they're going to tell us the variables they wish for us to represent the unknowns. Then, using those variables, those expressions you assign, read back through the problem and set up equations or inequalities or whatever. Here it's going to be three equations, right? We're going to have three unknowns, and our sentences in these problems should help us set up three equations. And then we'll solve these systems of three equations and three variables, just like in section 4.4 part 1. Alright. Okay, so I'm going to keep this up here. Hopefully you can see the computer screen and my paper. I got some paper in the lower right. So what I'm going to do is I'm going to set up the system, and then I'll make the paper larger so we can see how to solve it. And I'm going to solve all the systems in this video using what's called the elimination method that you've seen in previous videos. Alright, so reading through this, it says the sum of the measures of the angles of a triangle is 180, right, 180 degrees. The sum of the measures of the second and third angles is 4 times the measure of the first angle. The third angle is 12 more than the second. And they're saying let x, y, and z represent the measures of the first, second, and third angles respectively. Find the measures of the three angles. So again, they're saying let x represent the measure of the first angle, and we're having y All right, they told us to have y represent the measure of the second angle. I hope you've seen the ditto marks before. That just means I'm writing the same word again below it. Measure of second angle. And z, right, represent the measure of the third angle in this triangle that's being described. All right, so I've read through it. I've identified what they want from me, right, what they're asking me for, and assigned letters, assigned expressions to each of those unknowns. Now, here comes what I feel is the more difficult part for most people, is the setting up of the equations. Right, reading through the sentences again, and we're going to set up a system of 3 equations with these 3 variables. All right. So you're looking for key words, and usually the word is, or some verb, is, are, was, were, equals, represents where the equal sign is going to go. So look at the first sentence again. The sum. Now sum means adding, right? Addition. The sum of the measures of the angles is 180. So the sum of all 3 of these angles is 180. So that equation will be x plus y plus z. Right, there's the sum of the 3 angles. Is, right, equals 180. So there's the first equation. The next sentence gives me my next equation. The sum of the measures of the second and third angles is, alright, so the left side, the sum of the measures of the second and third angles. Now the second and third angles are represented by y and z. So the sum of the measures of the second and third angles would be y plus z. So the sum of the measures of the second and third angles is, right, equals, and then after the word is, it says 4 times the measure of the first angle. So the right side of this second equation is going to be 4 times x, right? 4 times the measure of the first angle. And then finally the next sentence will give me my third equation. The third angle is, so the third angle, which is z, is, right, equals 12 more than the second angle. So take the second angle, y, and then 12 more than that would be y plus 12, right? And you're looking for key words like more than. So here they are. Pardon me. 3 equations, 3 variables, and now I'm going to go and solve this system on, and I'll make the paper a little bigger. Right. Do this. Okay. Alright, so I'm going to do this with, now you can do it with the substitution method if you've heard of that. This wouldn't be too hard to solve. Find an x, a y, and a z that satisfy all 3 equations here. It wouldn't be hard to solve this one using what's called the substitution method, and I'll leave it to you to look that up. But I'm going to perform the elimination method. So for the elimination method, and again, you saw the video, hopefully you saw me work on section 4.4 part 1. That's where I'm going to rewrite these equations here, take all the variable terms to the left side, and leave constants on the right. And I'm going to line up the x terms, the y terms, and the z terms. Alright, so the first equation will stay the way it is. X plus y plus z equals 180, right? And I'll call this, E1 for equation 1. Now for the second equation, I could just subtract 4x, and that would give me all the variable terms on the left. So that would give me negative 4x Then I have, plus y, positive y still, and still plus z. Now, subtracting the 4x would leave me with 0 on the right side. So equals 0. And this is what I'll call equation 2. And finally, third equation, to get all the variable terms to the one side, I would just subtract y. And that would give me minus y, right, negative y, and positive, plus z equals 12, right? If I subtract y, there's still a constant of 12 on the other side. So I have what I want. Lined up the x's, lined up the y's, lined up the z's on the one side, the left side of the equal signs. And I've lined up the constants on the right side. And this is called equation 3, E3. Right. Okay. Alright, so notice that equation E3, right, equation 3, already has only two variables, right? This has just y and z. This has y and z only. Alright, so what I want to do now is take the first two equations. I'll keep the third one the way it is. I want to take the first two equations and eliminate x's. Right? Because if I do that, if I eliminate the x's from the first two, I'll have another equation with y and z. And then I'll have two equations with two variables. I'll have two equations with y and z, and you should be able to solve two equation, two variable systems, finding the value of y and z, and then I go back to one of the original equations with x and solve for x. Alright, so I'll keep equation 3 the way it is, and like I said, I want to make another equation with y and z. So to do that, I would have to eliminate the x's from equations 1 and 2. Right, so I'll use equation 1 and equation 2. So equation 1, x plus y plus z equals 180. Equation 2, negative 4x plus y plus z equals 0. And it would be very easy to eliminate x here. All I need to do is multiply this first equation times by 4. Right, everything on both sides, right? So that would give me 4x in the first equation and negative 4x in the second. Right, we want the coefficients of the variable we want to eliminate to be opposites. So first equation times 4, we had 4x plus 4y, alright, so that'll lead me to this, 4x plus 4y plus 4z equals, and then 4 times 18 is 40 plus 32, 72, so it'd be 720. And the second equation I didn't do anything to, right? Negative 4x plus y plus z equals 0. And now I can add the equations together, and that'll eliminate the x's. Right. Those are gone. You have 5y plus 5z equals 720. And then just to make the numbers a little smaller here, I'm noticing that all these numbers, all these coefficients are multiples of 5. So I'm going to take this equation here and divide everything on both sides by 5. So that'll give me y plus z equals, let's see, 122, 144. 500 plus 200 plus 20. Yep. Okay. So y plus z equals 144. And I'm going to call this equation 4, E4. All right. So now, look at equation 3. That has just y and z. Equation 4 has just y and z. So those two together, equation 3 and equation 4, they make a system of two equations with two variables. Negative y plus z equals 12, and y plus z equals 144. and I'm solving this system first. I'm going to solve this system for y and z, and then go back to an equation that has x in it and solve for x. Alright, well look, the coefficients of the y's are already opposites, -1 and +1. So I can eliminate the y's right now by adding the equations together to create a new equation. Left side I'd have 2z equals, right side, 12 plus 144 would be 156. And then I can solve for z easily here. Divide by 2. Right, so z would be 78. Right, 156 divided by 2. So there is the measure of the third angle. Right, remember, z represented the measure of the third angle. But that's not all I'm asked to find, right? I'm asked to find the measure of all three angles. So I've got the z value. Now I just need to go back up in here and one of these equations and replace z with 78 and find y. So let me go to equation 4. We have y plus z, right, which is 78 now. This is 144. And then I would subtract 78 from both sides. And that would give me 66. Right? 78 plus 66 would be 144. Alright, and there's the value of y. That is the measure of the second angle. Right. And now that I have y and z, I can go back to any equation that has x in it. I'll just go back to the first equation. Why not? Right, so I'm going back to the first equation where the sum of x, y, and z was 180. So x plus, and then y is 66, plus z is 78, equals 180. And this is x plus, again, these add up to 144, equals 180. And then I would just simply subtract 144. And that's 36. And there you go. The solution of this system is the ordered triple: 36 for x, comma, 66 for y, comma, 78 for z. Now I think they just want us to enter the value of x, the value of y, and the value of z separately. Just make sure you put them in the order that they're asking for. Now don't forget to check. Don't forget to check your solutions, x, y, z. Go back to the way the system originally looked and see if it satisfies our statements. Right, the sum of all three angles should be 180. Well, this is 36 plus 144. That is 180. That's true. The sum of the second and third angle, is 144. That should be 4 times the first angle. Well, 4 times 36 is 144, so that second statement is true as well. Remember, the third angle was supposed to be 12 more than the second, and 78 is 12 more than 66. So check on that. This is a valid solution to this problem. So back on the assignment page, those numbers are what I'm entering. Again, just pay attention to what variable was what. That first angle, x, measured 36 degrees. Just fill in the boxes, right? The second angle, y, measured 66 degrees. And 78 for z, right? And don't put the degree symbol, right? They just want numbers. And there we go, submit. And after each question, you'll either be told you're right or you're wrong, and you'll be given an answer explanation. Whether you're right or you're wrong, please read through the answer explanation. If you're right, read through it to make sure that the reason you were right was correct. Right? Or maybe they did it in an alternate way, and get an idea as to what would be an alternate method to solve the system. If you're wrong, definitely read the answer explanation. is maybe you'll be able to figure out where you went wrong, and so the next time you see a question from that objective, you can hopefully do better. So every question is very similar to this. I've noticed from this objective, this assignment. So example 2 or question 2 here on this objective. See the same type of thing about measures of angles in a triangle. So the sum of the measures of the angles of a triangle is 180, right? The sum of the measures of the second and third angles is 3 times the measure of the first. And the third angle is 15 more than the second. So this is very, very similar to the last one. All right, and they're telling you to let x, y, and z represent the 3 angle measures, and then find x, y, and z. And don't put degree symbols, right? Just find the numbers. All right, so again, I'll have the words up, and then now again, x represents the first angle measure, y represents the second angle measure, z represents the third angle measure. Right? And then we go back through and set up our system. The first sentence, again, the sum of the measures of the 3 angles is 180, so x plus y plus z equals 180, right? Same as last time. Second sentence, the sum of the measures of the second and third angles is, so y plus z is, and then 3 times the first, 3 times x. And the last one, the third angle is 15 more than the second, so z is, and then the second plus 15. All right. So again, the only thing that changed from this example to the last one is this 4 became a 3 and 12 became 15. This should end up being very, very similar. Obviously, the solution will be different though. All right. So what I'm going to do is, again, I'm going to write each of these. I'm going to try. I'm going to solve this by elimination. So I'm going to make sure I'm going to take all the variables to one side, the left side, and line them up, and all the constants to the right. So we have x plus y plus z equals 180. In the first equation, again, I'll call this equation 1. Then subtract 3x. We have negative 3x plus y plus z equals 0. There's equation 2. And then just subtract y here. We'd have negative y plus z equals 15. And there's equation 3. All right, and then just like the last example, see how equation 3 has only 2 variables? So I'm going to keep that, right? I'm going to keep equation 3 with y and z. And what I want to do is form a second equation with just y and z. So if I want just y and z, and I'm keeping the third equation the way it is, it means I'm going to have to eliminate x from equations 1 and 2 again. So equation 1 is x plus y plus z equals 180. Equation 2, negative 3x plus y plus z equals 0. And pretty simple here. To get rid of the x's, I would just have to multiply the first equation, both sides, every term, by 3. To give me 3x and negative 3x, right? Opposites. So the first equation now becomes 3x plus 3y plus 3z equals 3 times 18 is 54, so 540. And then the second equation, I didn't change, negative 3x plus y plus z equals 0. And now I add the equations together, right, because the coefficients of x are opposites. And I'll have 4y plus 4z equals 540. And then just as in the first example, I'm noticing here that all these coefficients are multiples of 4, so I'm just going to divide everything by 4 to make the numbers a bit smaller. So this will be 1y plus 1z equals, then we got 1, and then 4 goes into 14 3 times. One, and yeah, 14. 3 times 4 is 12 with 2 left. Oh, 20, 135, sorry. Alright, so y plus z equals 135. Okay. Alright, so now I'll call this equation 4. Right? So now look, equation 3 has just y and z. Equation 4 has just y and z. So those two equations together, right, equation 3 and equation 4, they form a system of just two equations with two variables, which we should be able to solve. So equation 3, negative y plus z equals 15. Equation 4 here, y plus z equals 135. And I'm going to solve this system for y and z, and then go back to one of the equations, probably the first one again, and solve for x. So as with the last one, look at this, the coefficients of y's are already opposites, negative 1 and positive 1, so I can just add the equations and eliminate y right now. And we'll have 2z on the left equals 150 on the right. Dividing by 2, we get z equals 75. All right, so there's the measure of the third angle. Z represented the third angle. And then going back to, say, equation 4, we have y plus, z, but z is 75 now, equals 135. And subtracting 75, we're seeing the measure of y is 60. All right, so the second angle would have a measure of 60 degrees. And then we can go back to the first equation, and that's x plus y plus z, and solve for x. X plus y plus z equals 180. So x plus 60 plus 75 equals 180. Now this is just 135 here. Subtracting 135, x equals 45 degrees. Okay, so the solution, these three angles are 45 for the first angle, 60 degrees for the second, and 75 degrees for the third. Again, don't put the degree symbols. And then check, make sure these three values satisfy all these equations. Now, I should go back right to the original. All right, let's go back to the original here. Here's what the original looked like. Now the sum of all three of these is indeed 180, so the first one's true. Second and third add up to 105. Oh, I'm sorry. Second and third are y and z. Y and z add up to 135, and 3 times the first, 3 times 45 is also 135, so the second equation is true. And is the third angle 15 more than the second? 75 is 15 more than 60, so all three of these are true, make up the solution of this system. All right, and I'll just enter those. Right, just make sure you're putting the right variable number next to the right letter. Right, x is 45, y is 60, and z was 75. Right, no degree symbols. Great. And again, all these problems are very similar. All right, you're going to see the next one too. Is again about three angles of a triangle. So I'll read it out. We have again the sum of the measures of the angles of a triangle is 180. Now there's no triangle mentioned, but it's a triangle. Three angles. the sum of the measures of the second and third angles is 2 times the measure of the first. Oh my goodness. The third angle is 26 more than the second. Find the three angles. So I'm just going to write, hopefully you've watched the first two examples. I'm just going to write that system. Alright. So remember the system, or the first one was the sum of the three angles, x plus y plus z is 180. The second statement, the sum of the measures of the second and third angles, that was y plus z. The sum of the second and third angles is 2 times the measure of the first, 2 times x. Now, again, I'm hoping they give you some sort of different descriptions here. Just pay attention to the wording, how you would form equations. I know in these first three examples all the equations are very similar, but they may not be all the time, so just be aware. Be careful. Be sure to read carefully the sentences. And then the last one, the last statement, the third angle, z, is 26 more than the second, so y plus 26. And so again, very similar to the first two, it's just that you have 2 here and 26 here. Alright, so I'm going to change this now so that I can perform elimination. So get all the variables to one side, constants on the other, and line up like terms. So the first equation I'm not changing, I'll call that E1. Second equation I'd subtract 2x, right? So negative 2x plus y plus z equals 0. There's E2, equation 2. Third equation I'm just subtracting y. So negative y plus z equals 26. Right, there's E3. And again, I'm gonna keep E3 the way it is. All right, I'm gonna keep that one. It has y and z, and then again eliminate x from the first two. So equation 1 and equation 2. So we have x plus y plus z equals 180. Equation 2, negative 2x plus y plus z equals 0. And all I would need to do to eliminate the x's from these is multiply the top equation by 2. Alright, so this, I'm going to take this over here. Alright, so if I multiply the top equation by 2, we'll have 2x plus 2y plus 2z equals 360. Then the second equation didn't change. Negative 2x plus y plus z equals 0. Now I can add and eliminate the x's because their coefficients are opposite. So we have 3y plus 3z equals 360. And then I'm going to divide by 3 because I noticed that everything here, every number, every coefficient is a multiple of 3. So we have y plus z equals 120. All right, and this is what I'll call equation 4. And then, just like the first two examples, very, very similar. The equation I kept, right, has y and z. This equation after elimination has y and z. So these two form a system with 2 equations and 2 variables, which I'll bring here. So looking at equation 3 and equation 4, right, we have this system, 2 equations and 2 variables. Negative y plus z equals 26, and y plus z equals 120. And I'm solving this system for y and z, and then going back to an equation with x and solving for x. Alright, so yet again, I have it set up so that the coefficients of y's are opposites, so I can add the equations now and eliminate y. There'd be 2z on the left and 146 on the right. Dividing by 2, we have z equals 73. So there's the z value. That's the measure of the third angle. That's what z represented. And then I'll just go into equation 4, and we have y plus z, so y plus 73 equals 120, and then subtracting 120, y would be equal to 47 degrees, right? So there's the measure of the second angle. And then going back to equation 1, again, any equation that has x in it, we have x plus y plus z. So x plus 47 plus 73 equals 180. Remember, these two add up to 120, and then I would subtract 120 to get x equals 60. So there's the measure of all three of the angles. The first angle measures 60 degrees, the second angle measures 47, the third 73. And let's go back and test that out, make sure it makes sense with our statements, right? Now the sum of all three angles is 180. You can add them all up. The sum of y and z, right, the second and third angles is, 120, which is twice the first angle, 2 times 60. That's also 120. And then the third angle is the second angle plus 26, right? The 73 is 47 plus 26. So all three statements check out. This is the totally valid solution to this problem. Just make sure you're putting them in the right order, right? So x was 60, right? Y was 47, and z was 73. All right. Again, read through the answer explanations. All right, so far it's been pretty boring. Every single problem has been very, very, very similar. Hopefully there's some different kinds of statements in this last example. And it's not. Once again, you may come across sentences that are a little different. Please just read carefully and try to translate the English into mathematical statements. They're not always going to be looking exactly like this, I don't think. Looks like these four are anyway. Alright, so same deal, right? The sum of the measures of the angles of a triangle is 180. The sum of the measures of the second and third angles is 5 times the measure of the first this time. And the third angle is 10 more than the second this time, right? So the only numbers that are changing are 5 and 10 from the previous couple problems. So again, x, y, and z are the first, second, and third angle measures respectively. Find x, y, and z, right? So just going to pull the paper up here and we'll write our system, right? So again, the sum of all three angles, x plus y plus z, is 180. The second sentence, the sum of the measures of the second and third angles, y plus z again, is 5 times the first angle, 5 times x. And the third sentence, the third angle is, so z is, and then 10 more than the second, y plus 10. Again, one more time, this is very similar to the first three problems I did in this video. Just please understand that you won't always see the exact same kinds of sentences. Right? Please just read carefully every time in case they throw in a new word or try to trip you up somehow. Alright, so I'm going to change this system so that all the variables are on the same side and lined up. Alright, so x plus y plus z equals 180. There's equation 1. Then subtracting 5x, you have negative 5x plus y plus z equals 0. There's equation 2, E2. And then subtracting y, we have negative y plus z equals 10. There's equation 3, which again I'm going to keep because it already has only two variables. So what I want to do now is, just like I've been doing, take the first two equations and eliminate x so that we create a second equation with y and z. So I'm going to eliminate x from equations 1 and 2. So first equation, x plus y plus z equals 180. Second equation, negative 5x plus y plus z equals 0. I'm multiplying the first equation by 5 to get rid of the x's. That way I'll have 5x and negative 5x, right? Opposites. Alright, so when I do that, I'll have the following. We have 5x plus 5y plus 5z equals 900. Right, 5 times 18 is 90. So 5 times 180 would be 900. Second equation I didn't change. Negative 5x plus y plus z equals 0. Then I can add the equations together. Since the x's are opposites, those will be eliminated, and I'll have 6y plus 6z equals 900. And then I'm going to divide everything by 6. I notice that all these values, 6, 6, and 900, are all divisible by 6. So then we'll have a simpler equation with simpler numbers. Y plus z equals 150. And this is what I'm going to call equation 4. Alright, then if you look at equation 3 and equation 4, right, they form a system with two equations and two variables, y and z. So negative y plus z equals 10, equation 3, and y plus z equals 150, equation 4, and I'm going to solve this system for y and z and go back and find x. Alright, just add them. Alright, add the equations because the coefficients of y's are opposites again. Left side you have 2z, right side you'll have 160, dividing by 2, z equals 80, right? So the measure of the third angle is 80 degrees. Then going back here, back to equation 4, we have y plus z, y plus 80 equals 150, and then subtracting 80, get y equals 70 degrees, right? So the measure of the second angle is 70 degrees. And then I go back to any equation with x in it. So yet again, I'm just going to go back to equation 1. X plus y, so plus 70 plus z, right, plus 80 equals 180. Right, so x must be 30. Right, because this is 150, and then I would subtract 150. So the first angle measures 30 degrees, the second angle measures 70, and the third angle measures 80. And then going back to our original statements, make sure all three are true, right? The sum of the angles is 180, check. Y plus z, the second and third angles, add up to 150, which is 5 times 30, so that's good. And then the third angle, 80, is 10 more than the second one. 80 is 10 more than 70, that's good as well. So these all check out. These form the solution of the system, 30, 70, 80, in that order. And that's what I'll enter, right? 30 for x, 70 for y, 80 for z. Right. And that's it for this assignment. Right. If you're doing everything right, you should only have to do 4 questions. And the assignment's complete. Now please understand, the questions I did in this video are not going to be exactly the same as the questions you're doing at home, right? When you're working on it on your own. You may even see different kinds of sentences than I saw. But remember, usually the word is, right? A verb, to be, is, are, was, were, equals, something like that. That'll represent the equal sign for an equation, and you translate the stuff to the left of it as one expression, the stuff to the right of it is another one. And you should be able to form 3 equations with 3 variables, and then take all the variables to one side, constants on the other, and solve by elimination as we did in section 4.4 part 1. Right. And I'm hoping that watching me go through these helps you a little bit, when you're working on this assignment on your own as well. And thank you very much for watching.